All right, in this video, we're looking at using the log rule for integration to do more than just the basics. All right, so you already know how to do some of this. Like, for instance, if you had something like the integral of x to the negative 1 dx to do, can't use the power rule because if you come in and you tried to add 1 and then divide by that new exponent, you'd wind up having a 0 down here, right? And so that is kind of the reminder that, hey, this is actually, I'm trying to integrate 1 over x dx. This is what that log rule helps me with. So that's going to turn out to be the natural log of x plus c. All right, so that's what's going on in 5.7. This one actually is going to make pretty good sense to you, I think, if you understand this right here. All right, and when you need to use it. All right, so let's go ahead and take a look at the 5.7. All right, I'm gonna break this up into a couple videos, so no one video is too long. All right, so in here we're trying to learn how to integrate something like 1 over x plus 16 dx. All right, so again, if we had tried to use, if we thought maybe we could do the whole let u equals, don't write this, go ahead and write this. Let u equals x plus 16 and then do the whole du equals 1 dx, and get u's in there instead of x's, and do something like this. And then think, okay, let me see, I'm going to use the power rule. When we go to use the power rule, okay, you'd have that whole division by 0 happening, and you'd say to yourself, can't do it. Oops, not something I can use the power rule on. And so this would wind up being the natural log of u. Okay, ln of x, absolute value of x plus 16 plus c. Okay. All right. Now, that's what we're dealing with in this unit right here. All right, so you know the power rule, but on the power rule, you know what'll happen. We just said is if you have trying to integrate that using the power rule, you can't do it because you'd wind up with u to the negative 1 plus 1 over negative 1 plus 1, and you can't do that. Can't do. That's the little red flag. That's the little thing that happens that should remind you that this is probably going to be a logarithm situation. So when the n, you can do this power rule as long as n is not equal to negative 1. You can use it if you have a higher negative exponent, or a different negative exponent like u to the negative 3. You could use the power rule on that. You could add 1 and divide by that and get it. And of course, you can do it when it's positive. Okay, so when the n equals negative 1, you can't do this right here. So this is the rule that we use. This is when the log rule for integration is going to be used. All right, so let me remind you about where this log rule for integration comes from. It's just the reverse of finding the derivative of natural log. So for instance, back in chapter 3, you did this. You had to do the derivative of the natural log of x plus 16. And what you would have done is 1 over the x plus 16 times the derivative of the inside, which just happens to be 1. So you get 1 over x plus 16 when you do the derivative. So you see, we're starting with that and we're trying to undo it. We're trying to figure out, okay, what was the function whose derivative would be 1 over x plus 16. And so it is going to wind up being the case where we'll use the natural log, and you do want to have absolute value on it because you can expand the domain of the natural log by using the absolute value on that. So the rule does include it, and you need to include that when you do it. Okay? All right, so that's the idea, and that's what we're doing here in chapter 5. Okay, so now we did a little bit with this, with the log rule for integration in section 5.1. Now we're just looking at working with it in a little more detail. Okay, look when you might have an inside function involved. See here, we've got some inside functions involved. So let's go ahead and give these a try. All right, so on this one, once you recognize that it's the log rule situation, then you're pretty much ready to go. So the u equals x minus 5. Du would just be 1. Okay, so this is pretty straightforward. So here what I'm trying to integrate is 1 over u du. So 1 over u, that's the u to the negative 1 situation where I can't use the power rule. So I'm going to use natural log. So this will turn out to be the natural log of the absolute value of u plus c, and u is just x minus 5 in this case. I didn't need to even make an adjustment for a constant or anything on that. And so that would be your answer, and you're done. Okay, right? This is pretty much just like it. To the right is pretty much just like it. It's just that here we're going to have an issue with a constant, because that inside function of 4 minus 8x, that winds up having a derivative equal to negative 8. Okay? And so here what we're going to wind up doing is taking the original problem and looking at it as 1 over u, and then we need to replace the dx. So I'm going to do like I did back in 5.5 and adjust so that I can replace the dx with negative 1/8 du. Okay, so I need to do the integral of negative 1/8 1 over u du. Okay, so I'm going to be able to bring the negative 1/8 down since it's a constant. Then I want to do the natural log of u. And why don't we go ahead and put the 4 minus 8x back in? And these are absolute value symbols, not ones. And then make sure to add the plus c, and you're done. Okay. All right. Now, when you look at this example, the one bottom right example, okay, this one here, okay. On this one, you might be thinking, oh, I'm gonna just be able to use the second stuff I do in 5.5. And you are kind of doing that, but when you let the u equal 3x squared plus 5, the du equals 6x dx, like that. It's and you make your substitution, it's going to give you a situation of this type. And so it's not going to turn out to be a power rule problem. It's going to involve logarithms. Okay, so the way to look at this one is to think of it as a 1 over problem times that 6x dx. And you can kind of tell that 6x came from right here. You want to get used to recognizing that before you get started so you can see how to think about this, how to make sense of it. All right. And so I'm not going to have to adjust anything over here and get rid of that 6 because I can just replace all of that with du. So what I'm trying to integrate is 1 over u du, and I know that I can do that. It's going to wind up being the natural log of the absolute value of u plus c, and then in place of the u, I'm going to replace it with the 3x squared plus 5, and that would be my answer. So that one, they were trying to be kind to us by giving us that 6x up there, which was the derivative of the inside function. Okay. All right, so I'm taking a look at number 10 and thinking about it like that last example, and I'm noticing that there I have the 1 over 5 minus x to the third. And look, that 3, that exponent 3 is on the x. It's not on the quantity 5 minus x. It's not this situation. Okay. It's not that situation or something where you might be thinking about using a chain rule like we did in 5-5. Okay. All right. So I'm looking at this. I'm thinking about trying to rewrite it so I can see the parts and where they came from. I'm going to let u equal the 5 minus x to the third. And when I do the derivative, I'm going to get a negative 3x squared. And I like the fact I'm getting an x squared because I can see x squared dx here. And so I want x squared dx there. So I'm going to move that negative 3 by dividing by it. So I get negative 1/3 du equals x squared dx. So basically I'm trying to integrate 1 over u times negative 1/3 du. Okay, so the negative 1/3 is kind of just carried along. I'm going to rewrite it just a little bit so things are in a better order. But then this winds up equaling negative 1/3 ln of u, and u is 5 minus x to the third, okay, plus c. All right, and it's okay to write it that way. Some of you, I noticed on the test, it's equally good if you think of it like, oops, let me write that better. It's equally good if you think of it like this. Okay, that says the same thing. So you can put like divide all of it by 3 and just leave that negative up on top, or just put a negative 1/3 in front of all of that. Okay. All right, so that's the first video.